Hi, this is Miss Andrea, and I run the science workshop for the Children's Museum of Houston, and I'm bringing you a project courtesy of the Harris County Department of Education, Case for Kids, City Connections, which is funded by the City of Houston. And actually, I'm not bringing you the project today, I'm bringing you a guest speaker. My guest speaker today is Gretchen, and she is going to be doing a liquid nitrogen exploration. It's super cool, so let's watch.
Hi everybody, it's Gretchen here with Children's Museum of Houston. I am the Science Education Manager here at the museum, and I'm here in Matter Factory, our exhibit that's all about matter, the stuff that the universe is made of. So we want to send a shout out and a big thank you to the Holt House Foundation for Kids that not only make the exhibit possible, but are making this video possible as well. And we're gonna go ahead and get started. So as you can see, I'm standing in front of a brightly colored representation of all of the elements in the universe. So chemists call this tool the periodic table of elements. And it's a tool that lets them study the elements' properties and help them to organize them by those properties. An element is a pure substance that can't be broken down into a new substance. And as you can see, there's 118 of these elements represented on the table. And all of the matter in the entire universe is comprised of these 118 elements. I see that our assistant over here has gone ahead and lit up a couple of the elements. So there are different ways we can group the elements. One of the things that we can look at are the elements that are found in Earth's atmosphere, okay? So you see we have carbon, nitrogen, oxygen, helium, neon, argon, and krypton. And today, I wanted to kind of introduce you to one of these elements in pure form, and that one is nitrogen. So I have a little bit of liquid nitrogen left that we ordered for our Pi Day celebration. And before it boils off, I wanted to make sure that you guys at home got a chance to enjoy it, okay? So I'm gonna go ahead and pour some liquid nitrogen into this bowl. But first I'm gonna put my face shield down. I have my regular glasses on today, so I can't wear safety glasses. So this face shield will protect me in case of any splashes. I'm gonna put on these really heavy-duty welding gloves, because we're gonna talk about just how cold the nitrogen is in just a second. So this will help to protect my skin in case it comes into contact with the nitrogen. Go ahead and put that. Okay, there we go. Let's see how much is left. Oh yeah, that's gonna be great. All right. Okay, so inside this bowl, you guys, we have an element in pure form. We have nitrogen. Nitrogen, as you can see, is in a liquid form right now, but it's quickly and rapidly boiling off and turning into a gas. So the temperature of the nitrogen is negative 322 degrees Fahrenheit. That is really, really cold. That's about 10 times colder than an ice cube, you guys. And so what happens is when that liquid nitrogen is introduced to a hotter temperature, like the temperature in this room, it begins to boil off. So it changes from its liquid state into a gaseous form. And that's what you see coming off the top of the nitrogen like this. And just to show you exactly how cold this is and the capacity it has for freezing things really quickly, we're gonna freeze these flowers right here. So these are just some carnations that we got from a grocery store. And we're gonna dump those in here. We might as well go ahead and do all of them for effect here. And so I'm gonna hold them in the liquid nitrogen for just a few seconds. And kind of flip them over. And you can kind of see as I put something that's a little warmer than the nitrogen into the bowl, that boiling accelerates and you get more steam like this. You can hear that crunch, crunch, crunch sound. That's the flower petals freezing very quickly. And so just having been in the nitrogen for a few seconds, you can see that they're completely frozen. They're completely brittle at this point. That's how cold this liquid nitrogen is, you guys. Incredibly cold, incredibly cold. That's why I'm wearing the safety protective gear. All right, so another thing that we can play around with are these racquetballs that I have here. So racquetballs have a little bit of bounce. Let's see if I can catch that. All right, but as you'll see when we drop them into the liquid nitrogen, that's quickly going to alter their ability to have that elasticity when we bounce them. So it's just gonna sit in there. We still have our flower petals freezing in there, but that's okay. And then we pull out the racquetball here and try to bounce that. We'll get a completely different effect. You can hear that sound, just how frozen it is. And we can do it out here a little bit so you can see a little bit better. And how the bounce, that elasticity has been reduced by the freezing. So again, we're working with really, really incredibly cold material right here. Okay. Another cool thing that we can do is we can look at how temperature affects the volume of a gas. So in this demonstration, we're going to explore Charles's law. So Charles's law in chemistry describes the relationship between the volume of a gas and temperature. And that relationship is a proportional one. In other words, as temperature goes down, the volume of a gas will decrease, so it'll condense. And as temperature rises, the volume of the gas will expand. So in our case, since we're working with something that's got an incredibly low temperature, remember negative 321 degrees Fahrenheit, we're going to see the gas inside this balloon decrease its volume, so it'll condense. All right, let's see what happens here. Just trying to get as much of the surface area of the balloon to touch the really cold liquid nitrogen as I can. And you can already see at home that the balloon is shrinking. But the important thing to note is that the gas inside the balloon is not leaving the balloon. It's just condensing. So it's taking up less volume. And so that's why the plastic of the balloon is shrinking. Or the latex, rather, sorry. Okay. So we get it all the way down here. Okay. And then when I increase the temperature by pulling it or moving it from the liquid nitrogen, the gas inside that balloon is going to expand again, back to its original volume. And so the balloon will look just like it did before I put it in there. Unless it pops. So brace yourselves at home, because that is a possibility. Let's see. Looks like it's doing okay. All right. There we go. All right. Now the balloon is still cold, but you can see that it's more or less returned to a similar volume before as we started. Maybe a little bit reduced. It's still pretty cold. There we go. All right. So there we go. Actually, we're going to put this down because we're going to use this measuring cup here. All right. And for our last demo, what we're going to do is try to accelerate the rate of the boil of the liquid nitrogen by combining it with a hot liquid. Okay. So we're going to put a little bit of the liquid nitrogen into this pitcher here. And I'm actually going to pour more from this sewer flask so that we don't have quite as many petals in there. We'll use all of it from the bowl, but I think that'll be too many petals. Okay. And in this pitcher, I've just got some warm water. Hopefully it's still warm enough. We'll see in just a second. I'm going to pour it into the top of this, and what you should see is a cloud of white fog that emerges. So we're going to really accelerate the boil of this by combining something that's much, much warmer than what's already in the pitcher here. Ready? All right, you can count down with me at home. 3, 2, 1. There we go. And you can't feel the steam at home, but I can tell you it is really, really cool. So I can feel it even through my lab coat how cool the steam is. All right, and so this is our liquid nitrogen right here. It's so cold that it's actually frozen to the top of the cart here. So we'll have to let that cool down before we can move the pitcher. All right. So again, this is liquid nitrogen. It's an element. It's a pure substance. Okay. It's represented right here on the periodic table. Okay. And I hope that you enjoyed learning a little bit about this really, really interesting element. I invite you to explore at home and find out more about nitrogen, where you can find it in the world. And feel free to share anything that you learn with us back at the museum. We'd love to hear from you. Hope you guys are doing okay and staying safe. I'm Gretchen, and I'll see you next time. Bye, everyone.